Hello, grade 9. How are you today? I hope you all are safe and well. We studied before about how can we make salts using carbonates and using acids and metals. Today we will learn about how can we make salts using acids and alkalis. I mentioned earlier in our lessons that we can neutralize an acid using an alkali, which is cancelling out the acid by alkali or alkali by acid, and the product will be water and salt or salt and water. So when we studied about how can we make salts with acids and carbonates, we said that we need to react an acid with excess metal carbonate to get salt and water. And also we need to evaporate this water to get the crystals. So we need to filter to remove the unreacted metal carbonate, and then we need to heat to remove the water, and then we can get the crystals of the salt. So today we will see how can we do this using acids and alkalis, which we call this reaction neutralization reaction. So open your books on page 204, grab your highlighters and follow me please. Making salts, acids and alkalis. Sodium chloride. We all know that sodium chloride is the salt that we are using for food, and we can get this from water, with seawater, or we can get this by reacting some chemicals or some alkalis and acids in the lab. So how can we do this? Like exactly? Let's read and explain more about it. Sodium chloride. Sodium chloride preserves and flavors food. It helps to dye clothes. It's used to make other important chemicals such as chlorine and sodium hydroxide. So can you remember what is sodium hydroxide? Sodium hydroxide, is it an alkali or an acid? Of course it's an alkali that we are using it in the lab, and we are using it to clean sewers. This is the sodium hydroxide. On large scale, sodium chloride is extracted from the sea or mined as rock salt. But you can make sodium chloride in the laboratory. Read on to find out how. So how can you make salts in the lab? First, as usual, we need to choose the reactants. We need to choose carbonates like sodium carbonate or another alkali, or we can react chlorine. But using chlorine is too hazardous because chlorine gas can be very poisonous. Sodium plus chlorine, sodium chloride. This is like very easy to do, but it could be hazardous. So how can we choose the reactants? In any reaction or any experiment, you have to take care of these risks. You have to control risks and use the most safe way to react chemicals or to produce any product that you want. So just don't use any chemicals or choose any reactants. You have to even to consider the hazard. So how to make sodium chloride from its elements is described on page 114, but burning sodium in chlorine is hazardous, and the sodium chloride produced is not pure. We all know that chlorine in room temperature is just green poisonous gas, so that's why it's hazardous. So we can add sodium to chlorine and produce sodium chloride, but in this way we cannot get it pure. So how can we get it pure? We have two ways, two other ways. We can extract this by distillation to get the sodium chloride from the seawater, or we can use reactant in the lab. Like we can make sodium chloride by neutralizing acid with alkali. So we can use hydrochloric acid because it contains chlorine, and we can use sodium carbonate. So when we react these two together, they will neutralize each other, they will cancel each other out. We will get sodium chloride plus water. So I need you to remember, how can we extract this sodium chloride from the water? Of course, we need to heat the mixture, but are we just going to heat the mixture exactly immediately to evaporate the water, or we have another step before? So let's see together. How much sodium carbonate? So in any experiment we need to know the quantities of the chemicals that we are using it for reaction. So not just like adding chemicals without knowing the measurement or without knowing the quantity. So how much sodium carbonate we should add, or how much sodium carbonate that should react with the hydrochloric acid to produce sodium chloride? When dilute hydrochloric acid reacts to neutralize sodium carbonate, there is nothing to see. Both reactants are soluble in water. How do you know how much acid to add? So here there is a student, Azali. Azali follows the stages shown in the picture below to make sodium chloride crystals. So first, she added diluted hydrochloric acid and universal indicator, and the solution is red. Here the solution is red. That shows the solution is acid. Then she started to add sodium carbonate solution to make a neutral solution, and the solution is green. So here, how can we know that the solution is neutral? In this case, the color will start to change. So when the color change, that means it start to react. So here she adds charcoal powder. This removes the color. So this is the reason why she added the charcoal powder, just to remove the color. And then she started to filter the black charcoal powder, because here the charcoal is not soluble, so it will just stay in the bottom of the flask. So she put here a filter paper, and she started to filter the solution, because solution is sodium chloride and water plus water. Then sodium chloride solution is down here. She started to evaporate it on water bath, over a water bath, just to evaporate the water, and about half of the quantity of the water is evaporated. Then she kept it in a very warm temperature or room, just to make it to evaporate. After a few days, she got the sodium chloride crystals. So this is one of the ways how can you produce sodium chloride in the lab. So as we said, first we need to add dilute hydrochloric acid, then add sodium carbonate solution. And you have to be careful when you add sodium carbonate solution. You have to add it slowly. Okay, so you get the quantity that you want. And then when the color changed, she added charcoal to remove the color, because it's green. Then she filtered the charcoal with filter paper, and then she heated the mixture over water bath. Not in this case, she will not lose much sodium chloride. And then she got sodium chloride crystals. Another student called Bim, he was using different method to make sodium chloride solution. He uses burette and pipette. This one called burette with like a water tab here, it's like a valve that we are using to control the water dropping. And the pipette or pipette, it's like the dropper, but it's we have it in the lab. It's plastic. We're using it to suck the solution or transfer the solution from one container to another, because sometimes we need specific quantities. We don't need to pour it. Sometimes we need to add drop by drop, so we are using it. This is called pipette. So this BIM, he was using this burette and pipette and an indicator or solution to measure the volume of acid needed to exactly neutralize 25 cubic centimeter of sodium carbonate solution. He starts to pours away this mixture and repeats the method without indicator. Then he heats the sodium chloride solution over a water bath to get the crystals. So this was his way, as now they start to evaluate the two methods. So which method is the more accurate or better than the other? So they need to evaluate them. Both Azali and BIM started with the same amount of reactants. BIM made more sodium chloride than Azali. So how did he know, or how did they know? By measuring the sodium chloride crystals after the evaporation. After they finished their experiment, they need to measure the quantity of the crystals that they got. The students evaluated their methods to work out why. Azali filtered her mixture to remove the charcoal powder. Some of the sodium chloride solution soaked into the filter paper. Azali lost some of her product. So this one of her mistakes. So she lost some of the products by the charcoal. When she added the charcoal sucked some of this sodium chloride. So she lost some of it. BIM did not need to filter the mixture, but he did not lose any product in the first stage of his method. BIM and Azali heated their sodium chloride solution over a water bath. So this is a good step or good stage good step to not to lose more of this sodium chloride. Some of the water evaporated. The method lost very little sodium chloride at this stage. So how does this happen? This stage does not explain why they made different amounts of sodium chloride. The difference is explained only by Azali's filtering. Azali's and BIM discussed their results further. So here, when BIM measured his quantity, when he started with the same amount of reactants, he found that he lost a little bit of this sodium chloride, but he couldn't explain exactly where, in which stage, because he didn't use any filtration. So here they discussed the results further in their results. Azali said, I only had to do my reaction once. I lost some sodium chloride when filtering, that's all. So you have to know where is your mistake, or how did you lose some of your reactants, or why your measurements is not accurate. In this case, that's why you need to write every point down. You need to have your notebook and write every step and everything you did, even the mistakes that you can see as simple mistakes. Sometimes these simple amounts that you lost, or simple mistakes, this can change the result completely. And BIM said, I did my reaction twice. I had thrown away my first mixture of sodium chloride solution and indicator. So this is lost. So I wasted lots of chemicals. Azali removed the indicator from her solution, so she wasted less. Maybe Azali's method was better after all. So also when he threw away the mixture, he lost chemicals, and this is his mistake also, because he wasted these chemicals. So next time he can use Azali's method by removing the indicator using charcoal or something, And but also when he started to see by using charcoal, he found that charcoal sucked some of this sodium chloride, and but he can see that this way is better than him. So this lesson was all about how can you perform your experiment, and you can minimize your mistakes or control your mistakes by writing down everything that you are doing. And you can use preliminary work by using or choosing small amounts of chemicals, not important to be like large amounts, just to minimize the mistakes or the wrong results. So now let's go to the summary of the lesson. Making salts, acids, and alkalis. Make salts from acids and alkalis by reacting an acid with an alkali. Use an indicator. Heat to remove the water. So you can use hydrochloric acid plus sodium carbonate to give you sodium chloride plus water, and then you can evaporate it to get the sodium chloride crystals. Every time we have an experiment, or we are doing an experiment, we have to measure the reactants before the reaction and the products after the reaction, and then we need to measure the amount of the crystals, the dry crystals that we got. In this case, we will know how much we lost, and we will not repeat this mistake again. So this was all about making salts, acids, and alkalis. I hope you understood the lesson. Please write these notes in your notebooks, and don't forget the yellow box. I hope to see you soon, and we will meet in a new lesson. Bye bye.